Hey, welcome back to Global Environment. We're still talking about global warming. Now I want to show you some of the evidence that global climate change is occurring, something special is happening, and at first we're going to look at basically CO2 levels because, again, CO2 is a potent greenhouse gas. Okay, so one of the most important bits of information comes from the Mauna Loa curve or the Keeling curve. And there's a story to this. It almost sounds like a joke. There's this guy, David Keeling. He wants to do this study where he's going to measure CO2 concentrations in Hawaii on a mountain. You know, you can imagine the grant coming in because what a great place to live. So he chose Hawaii because when you think about it, and on a mountain, CO2 is well mixed. So you get a really good idea of what's going on in the northern hemisphere. If you use a place like Hawaii, if you use Los Angeles, you could get real local effects. Hawaii's a little better. So we started this work in 1957, and the data he generates is incredibly famous. So let's look at what he's got. He came up with a graph like this, which shows CO2 levels over time. And what was amazing is you actually saw two very important trends here. The first thing they saw were these oscillations. You see these oscillations? Now this is very amazing because, again, CO2 levels. And what they found is during the summer, the CO2 levels would drop. And think about it, that's because of photosynthesis in the northern hemisphere. And then during the rest of the year, when photosynthesis would slow down, but respiration would still take place, you saw an increase as CO2 is released back in the atmosphere. So you're almost seeing the Earth breathing here. Now the other important trend is that basically CO2 levels are rising quite a bit over time. And this has been extended. And the CO2 levels in the atmosphere right now are about 20% higher than they were when industrialization started, about 100 years ago. So 20% increase in atmospheric CO2. Now, atmospheric CO2, the concentration naturally is very low, less than 1%, but 20% increase in this is pretty amazing. Okay, so that's the Keeling curve. Very important bit of data, very famous. Now, I like to include this. This is kind of a Keeling curve or Mauna Loa curve that, again, you've got CO2 levels over here, CO2 levels, and time right here, but you also have latitude over here. And what you see is your normal oscillations in the northern hemisphere, up and down, that seasonal effect. In the southern hemisphere, you see something a little different. You see, basically not as much in the amplitude department here. See, it's a lot lower. And why is that? There's less land area in the southern hemisphere. And you also can make out over here that the phase is the opposite of the northern hemisphere. And that makes sense. You'd expect summer and photosynthesis to occur during the northern hemisphere's winter. So it's really kind of a neat graph because it's really consistent with what we know about the Earth. Okay. Now, CO2 is not the only greenhouse gas. It's important because it has a really high residence time, and that's important to remember. The CO2 coming out of my mouth right now while I'm speaking will probably be in the atmosphere for the next 100 years. Methane, on the other hand, has a lower residence time, but it's more potent. Now, what trends do we see in methane? If you look at this slide, again, increasing methane over time. Where does it come from? Rice paddies. Quantity of those are increasing because of increasing population. The back end of cows, it's 18 times more potent than carbon dioxide, but there's also less in the atmosphere. But it contributes. And when we're talking about positive feedbacks, we talked about that earlier in the course, Think of a scary scenario. Methane can be released when wetlands or permafrost in particular melt. So methane's released. Now think about if we get some global warming because of industrialization, that causes the temperature to rise, the permafrost to melt, methane to be released, which causes more global warming. And this is a kind of a deadly cycle. These are the kinds of positive feedback loops we have to worry about when it comes to global warming. Okay, so the global carbon cycle, where is it coming from? Where is the extra carbon coming from? You can see that here. Most of it's from fossil carbon emissions, all that coal and oil and natural gas we're using, but also deforestation contributes some. And, who's doing it? You can see the global increases on this slide, but for a long time the United States has been a leading contributor because of our affluence, because of our population. China has just recently passed us, but if you look at the cumulative effect, the West has really done a lot to exacerbate global climate change and CO2 in the atmosphere. All right, so another shot shows global climate change can be due to deforestation, slash and burn agriculture contributing, but again, most of it is because of our affluence burning fossil fuels. Okay, we're going to stop there and start to look at more evidence of global climate change, of global heating, and I'll see you next time on Global Environment.